In landscape architecture, powerful digital tools such as CAD are now invaluable to the design process. However, physical tools and materials still retain an important place in the design process, and the relationship between the digital and physical tools is often time-consuming and frustrating. The design process has become fragmented by the frequent input and output processes between the physical representations and the digital models. Illuminating Clay was developed in response to this problem. It is a novel system for the real-time computational analysis of landscape models. Users of the system alter the topography of a clay landscape model while the changing geometry is captured in real time by a ceiling-mounted laser scanner. A depth image of the model serves as an input to a library of landscape analysis functions. The results of this analysis are projected back onto the surface of the workspace and registered with the surfaces of the model. An evaluation of Illuminating Clay was undertaken to determine how effective it is in a typical landscape design process. The evaluation used protocol analysis, a technique where subjects are asked to think out loud as they are solving a design problem. Protocols were collected on video and analyzed from one long-term project and 4 short-term exercises in landscape design. The long-term project took place in the context of a graduate-level site design class at MIT. Over a 6-week period, students designed a development plan for a 200-acre site. Illuminating Clay was used alongside CAD and physical tools such as paper, pencil, and scaled rulers. The short-term exercise had subjects place 2 buildings on a 1-acre site with minimum cut and fill and accounting for drainage. Students from the site design class performed this exercise in small groups. Secondly, professionals were recruited from local landscape design firms to perform this exercise. The goals of the user evaluation focused on 3 proposed advantages of Illuminating Clay. First, by limiting resolution, it could be an appropriate sketch medium for the creative or early design phase. Evidence from the protocols substantiated that Illuminating Clay supported sketching or the roughing out of possible solutions. Designers achieved initial solutions as quickly as with paper, pencil, and scales. Second, it could not only save the time, cost, and hassle of digitizing 3D physical models and outputting virtual 3D models, but could better inform the creative process by providing computational feedback to manipulations of a clay model. The computational feedback from Illuminating Clay added greater viability to their solutions. They could know in the first stages of design that their solutions met the required physical constraints of drainage and slope, something that usually occurs at this stage by eyeballing. Third, that Illuminating Clay would, like physical drawings and models, facilitate communication among designers, but with the added dimension of much richer dynamic information. Illuminating Clay also supported communication among designers in the same way that physical models do, by allowing designers to describe and gesture in a 3D space. However, Illuminating Clay offered an enhanced ability to show proposed alternatives, making communication more specific and concrete. Specific limitations compared to current practice was the fixed location of Illuminating Clay and the size of the scanning area. Concern was expressed by some designers that computational feedback might draw too much attention away from the formal aspects of a design, risking